Alright, I'm a little bit late. I had to take a final. I kind of waited the last minute, but I think I did pretty good on it. And I did already kind of read the problem, so I kind of know a little bit what I'm going to do. So we need to find regions within like a grid. A region is just like a bunch of characters of the same value that are touching, basically. And we need to find its area and its perimeter, multiply those together, and then that's going to give us the price of the fencing, and then sum up all the fence prices for each region. Okay, and I think I'm gonna do this with a DFS. I think I can do this with a simple DFS. So let's add our new day here. Day 12, that's what I made it to last year. It's kind of laggy for a second. I don't know. VS Code is mega slow, but I like it, okay? Test day 12 .java, and let's just get our sample inputs in here. I was given 2 of them this time, so let's use both of them. Test day. Come on. Implements day. Let's let Java wake up. And let me think about my strategy before I forget. First of all, I'm going to have like a Boolean array, just 2 dimensions, to keep track of the nodes that I have already visited. Then I'm going to iterate through every cell in the grid. And if that cell has not been visited, I'm going to do a DFS. And for each iteration of this DFS, I'm going to get all the neighbors just up, down, left, right. That's all I need to do. And if a neighbor is not of the same value as like the origin, the one I started the DFS in, add to the perimeter. If it is of the same value, DFS that node. I should also say, if it's not of the same value or if it's out of frame, those both count for perimeter. And that'll give me the area and the perimeter. And just add that to like a running sum. And then, move to the next node. If the next node's not been visited, on and on. I think that should work. Yeah, you didn't put the package in there, goofball. Java projects. Package. What is this package? AOC dot days. Let's add these unimplemented methods. Same down here. What's going on day 11? Oh. I never finished my test for day 11. I'll come back to that. Let's do the same thing here. Don't forget to add those compiler flags. Okay. And in here, I'm going to have a day 12. No. I'm going to have day 12. Also going to have a couple of samples here. Sample 1. I'm also going to use my sample 2. And let's get those real quick. So the first example, yeah, the first example, the total price is 140. So for this guy, total price should be 140 for sample 1. And then test part 1. And then for part 2, I might just do this actually. I don't need to do both parts. 1930. Yeah, let's just actually do one. It's fine. And is this going to be huge? Should I do longs again? Yeah, I think you should. That's pretty cool. I like the look of that. Whoa, cool. But I have a feeling I should use longs again. That's why my test A11's mad at me. So long expected was 1930, right? It's 1930, right? Yeah, 1930. Actual is day 12 dot part 1 sample. Assert that those are equal. Expected actual. Okay. Long part 1. Just going to take some data and we're going to have a grid in this one. It's going to be a character grid. We're going to have a M and an N. And I'm also going to have a visited. Yeah. Visited. And down here, I'm going to initialize all that stuff. Grid is going to be parsers.char matrix data. M is going to be grid.length. And N is going to be grid 0.length. And visited is going to equal a new Boolean array with M rows and N columns. Let's say that this throws an exception. And we're going to have a DFS, like I said. So I'll have, let's see, how am I going to do this? I could, let's see. How am I going to do this? I could do something janky like return an array with 2 elements for perimeter and area. Let's start off with that and see how that looks. So I'm going to have a long array DFS and we're going to have an I and a J. And base case we actually don't need a base case here, right? I am going to use directions. Final int di final int dj. And we're going to go up, down, left, right. Up, down, left, right. And we're just going to go for direction. It's less than 4 plus d. For each direction, let's get the neighbors. Or let's just get the neighbor here. The neighbor row is going to be I plus did. The neighbor column is going to be j plus djd. And then we want to check some things here. I'll make like a helper. Let's just do it in place first, see how ugly it is. If we're out of range, oh, we also need to keep track of the origin, whatever we started it with. So if, first of all, if we're out of range or we're not equal to the origin, that's going to be part of the perimeter. So I could actually do that here. Long area and perimeter. I'll just say perim equals new long 2. So if the neighbor row is less than 0, or the neighbor row is greater than or equal to m, or the neighbor column is less than 0, or the neighbor column is greater than or equal to n, or grid neighbor row neighbor column is not equal to the origin, that's going to go in the perimeter. So I'm going to say area perim 1 plus equals 1. And we also want to put that, no, we don't want to put that in our visited because we didn't actually visit that one. Right. I do need to say that up here. Visited ij equals true. Okay. Relax. Else if I'll say else if grid neighbor row neighbor column is equal to the origin, add that to our area. So we'll say area and perimeter 0 plus equals 1. Is this going to work? So for each direction, yeah, add that to the perimeter. Perimeter. I should keep this actually in the, I should carry this around as a parameter, I think. Yeah. And then this would just return a long. plus equals 1. And then at the end, just return. Well, yeah, we want to have a sum, kind of a sum going too, right? What am I doing? I don't know. I think this will work. Area and perimeter, this is not going to work. 0 times area and perimeter 1. What do I say? Oh, what do I do here? It might be better if I keep this just like up here. Let's just do that. Whatever. Area, long perimeter. What if I just do that? Area equals 0. Perimeter equals 0. And then this could just be void now. And I don't need all this. And now I can just say area. This is perimeter. Perimeter plus equals 1. I can say plus plus perimeter. And plus plus area. Plus plus area. Plus plus area and then DFS. I DFS right here. Origin. Neighbor row. Neighbor column. And I don't DFS this neighbor. And then at the end, nothing. I don't need to do anything. Oh, right. If grid neighbor row neighbor column is not oh, sorry. If visited neighbor row and neighbor column and so if it's not visited and that neighbor is the same as the origin, add to the area and DFS. I think this will work. And then at the end, so just run that DFS. Actually, you need to go through each character, right? For each. Is less than M. J equals 0, J is less than N plus plus J. And if this thing has not been visited, if grid, so I keep doing that, if not visited, IJ, DFS that sucker. DFS, the origin is going to be the actual value there, and then pass IJ. And then at the end here, I could just return area times, oh, each one of them needs their own kind of thing, right? Long sum. So after I complete a DFS, I need to say sum plus equals area times perimeter. And then I need to set those back to 0. It's kind of janky, but I think this works. And then just here you return sum. Sum. And then up here, string data equals readers dot file to string file name And let's print out part 1. I tank this work. What's wrong with you, day 12? Oh, we don't have the package. Package aoc.days. And let's see if that work is. Okay, what did we actually get? Let's grab that. That's going to be our day 12 sample. Day 12 sample. Day 12 sample. What do we actually get? A big old number. So why wouldn't this work? So part 1. If it's not been visited, DFS it. Sum plus equals that area in the perimeter. Set those back to 0. This part seems right. And then for the actual DFS, mark it visited first. And then for each direction, yeah, I only need to go up, down, left, right. I don't think I need to. Yeah. For each direction, which is up, down, left, and right, get the neighbors. Oh, there's our problem. Nope, that's I. J. And if we are out of range, or that thing is not equal to our origin, then add to the perimeter. Else if it's not visited and it's equal to the origin, then let's DFS it. Well, let's add to the area and then DFS it. That seems like it should work, right? Now, why wouldn't that work? Let's try it with the little one. Let's try it with this little example. Sample 1. Let's do a day 12. Sample 2. Sample 2. We got only 100 for that, so that's definitely not right. So let's see here. What is the first perimeter that we're getting here after this DFS? So let's print out char. And let's print out the area. And let's print out the perimeter. Okay. Oh, why do we only get 3? Wait a minute. I should add to the area up here. Should add to the area first. Yeah. There it is. And then the big one should be 1930. Boom. And let's do the large one. Let's do the actual input now. Day 12. Run that pretty fast. Let's just like make sure my tests pass again. The test is the same thing, but all right, we're gonna go with this. Boom. Yes. Yes. All right, what's part 2? Okay, part 2. Fortunately, elves are trying to order so much fence that they qualify for a bulk discount. Under the bulk discount, instead of using the perimeter to calculate the price, you need to use the number of sides each region has. Huh? Instead of using the perimeter to calculate the price, you need to use the number of sides each region has. Each straight section of fence counts as a side. Okay. Oh my gosh. Regardless of how long it is. Oh crap. So instead of using the whole perimeter, I need to use how many sides there are. That's tricky. So like the cost of this one should be 4 times 4. Yeah. Crap. How am I gonna do that? First part was easy. Okay. Wait, what sample were we using for the test? We were using this one. Where's that one? We don't have that one. The larger example from before now has... It was this one, right? Yeah. It's now going to have 1206 as the price. Okay, part 2. Part 2. Now how are we going to do this? Sides. So for sides, and Yeah, what makes something a side? This is gonna be trickier. I can still get the area pretty easily with the DFS. But how do I, like, distinguish a side? So if I'm on, like, one... Okay, let's say I'm doing a DFS and I find one that's out of range, or it's not equal to the origin, and and I was gonna say, let's say, like, I'm looking left, right, and I'm looking at an edge. I could And you can't just say, well, I have this many edges in this column because some of the edges could be separated by, like, a blank space, and that would be two sides. How the heck am I gonna do this? How's I gonna do this? Well, I have not pushed in like 3 days. Holy crap! I'm just gonna go ahead and do it right now. You should not push with bad or failing tests, but oh, I didn't add. Dang, dude. Sometimes part 2's harder. Sometimes part 2's easier. Part 1 was pretty simple. Let's stare at this for a second. So how can I... How can I know when I have a side? What makes a side different than... well, like here, say these are all in the same row, and you could just count each contiguous column index that you have on this row, and that's a side. Or like looking up, right? If I look up, take a step, look up, take a step. As long as I can keep going, check up. That's all one side. As soon as I have to stop, that's not a side anymore. So I could, like, DFS. Oh man, how am I gonna do this? Tricky. Now, what kind of characters are in the input? What's that Oz's characters? Letters. So I could put like some signal values in there and do some stuff. Oh, that would be like super brute force. That would be so slow. Like if I did a DFS to find... I would have to like reset them or something. That'd be super mega slow, wouldn't it? Yeah, that'd be super slow. That'd be like O of n times k, where I have k regions just for that part. To like, what I'm thinking is not a good idea, but is what I was thinking. You know, iterate through every cell. If it hasn't been visited, let's DFS it. Mark it with a signal value, like -1. Mark every cell with a -1. That gives me the area. And then I could loop through. I could just do like a scan, top to bottom. Like this first one here. I got these X's, these 5 X's right here at the top left. Just loop through left to right. Oh, here we're at a -1. And then just as how far can we move to the right? 1, 2. And then once we get to a cell that's not, or we go out of range, we know we're done with the side. We're done with the side, but we have to keep going. We got to keep going. There might be more -1s. So you have to go through the whole. You got to go all the way to the end, and then go to the next row. And it would be like a sliding window thing. So you'd move your left all the way until it, so you'd have to be looking, you'd have to check all 4 directions first of all. So if I'm checking up, do a sliding window, move my left pointer until I'm at an X, and above me there's not an X. I know that this is a beginning of a side, and then my right pointer just starts, my right pointer just starts there, and then just loops until I'm not at an X, and then I know I've completed one side, and then I have to move my left pointer equals right now, and then move left pointer again until you find an X with an X not above it, you know. And that gives you all those sides. That gives you all the top sides. And then you'd have to do the same thing for checking left, right, and down. Honestly, you could check up and down at the same time. And you could also check left and right at the same time. Would you want to, though? You might as well just split them up. I mean, it's going to be the same net operations if I was going to do that. So just go through checking all the upsides, go through checking all the downsides, go through checking all the left sides, go through checking all the right sides. Super mega slow though. I could like keep track of the min and max indices for each region, so I don't have to loop through the entire array every time. Yeah, what if I just did that? All right, we're brute forcing it. Here we go. Oh, man. There are better solutions tomorrow. Let's get it done tonight. So, let's just move part 2 down here. Let's get out of the way of my decent part 1. And make that grid. It's basically going to be kind of the same stuff I got going on here. Yeah, I feel like if I cover it with a signal value, you'd want to loop back over it and reassign it or something, right? Yeah, totally. So we have our grid. And our visited. We're just going to go through each cell first. And if it has not been visited, we need to do a DFS. If it hasn't been visited, we need to do a little DFS. And we're going to have our own DFS down here. It's going to be basically the same, but for now, throw a little duplication in there, no big deal. Visited is true. Plus area. Yeah, we'll use area. That's fine. Area is okay to use. Perimeter is not going to work the same. This time we'll just say continue if that's the case. Visited equals true, and I'll say grid IJ equals like a period or something. There's no periods in there, right? I don't believe so. Nope. Equal to period. DFS. Yeah, what's wrong? Oh, it's a duplicate. So we're going to DFS it. That's going to give us the area. So DFS origin IJ. And we have the area now. Got the area. Now we want to get the number of sides. Now we want to get the number of sides. So we'll say, just say count sides. We can do that. So we're going to count the sides, and then we want to reassign everything, reset. So int num sides and void reset. Reset's going to be, it could be better right now. Just do it like this. I was saying something earlier about getting the min and max indices for a region so I don't have to loop over the entire grid to reset it. I'll do that in a little bit though. Oh yeah, you do want to have the origin in here. If char 0 equals period. Oh, not char, grid. Grid. Then grid ij equals the original value. That's all that's got to do. And for getting the number of sides, this is going to be ugly. So for each direction, first let's have a sum here for the number of sides for each direction. D is less than 4 plus D. For each direction, we want to count how many sides there are in that direction. And to do that, we're going to have to loop through the entire freaking grid. So 4 equals 0. Yeah, super brute force. It's probably, it should be able to finish though. It's not going to be like exponential or anything. Okay, looping through the entire grid. Now we want to have a left and a right. Left is going to be, well, actually, oh crap. No, this is not going to work. So for checking up and down, let's do this. Check upsides, check downsides. I'll see what I'll see what's similar, what we can pull out. Check right sides. I'll say left first. Left sides. Check right sides. And for the upsides, we're going to loop through every row. We're going to loop through every row, and then we're going to have a left pointer starting at 0. This will be the column index, but I'm going to call it left because I'm going to do a sliding window. Left equals 0, and then while left is less than m, and and grid I left is equal to well, it's actually going to be period at this time. It's equal to period. And the up is out of range. And I minus 1 while left is less than m, sorry, left is less than n, and we're on a dot, and see, we're on a dot, and the one above us is a period. And yeah, so, and I is greater than 0, and grid I minus 1 left equals a period plus plus left. And then once that's there, we're going to have a right pointer. Right equals left. And then basically the same thing again here. Crap. Yeah, you do want to kind of put this whole thing in a loop, actually. Another loop. While left is less than in. And while left is less than in, and this cell's a period, and the one above us is a period, then move left to the right until the one above us is not a period. If the one above us is out of range, then we can start counting this as a side. Sides. And then right to left. Kind of the same thing, while right is less than n. And is it literally get the same condition? It's like the inverted condition. While right is less than n, and grid I right is equal to period and the one above us is not, or sorry, if I is and I equals 0 this time. I equals 0 or grid ij is not equal to period. Then move right. And at the end of that, wait, how am I gonna? I might want to do something like this. If left is still less than end, like we didn't go all the way to the end, that means that we began a side. Set right to left, and then move this sucker until the side is done. And then here I can count a side, or yeah, plus num sides, and then set left to right. I think that works. So that's for the upsides. Oh my gosh, that's gross, dude. So this should give me 1. Let's see if it does that. See if it even does that. What? Oh. Oh yeah, you can take this whole shebang outside of that. Or you can just do this. And let's just see if we get the right number of upsides. It should be 1 for that first one. Count sides. We said num sides. I'll say count sides. Oh. I should say 1 for the first one. It's executing right now. Oh gosh. What? Where are we stuck at? Oh, wait a minute. Wait, where's part 2? Oh, we should be doing DFS 2. DFS 2, please. I think it might. I'm still not doing something. Yeah. Wait, we're not even getting. Yeah, we are. So we're not leaving the DFS or something. I see it. I don't know if that was my problem or not, but it was a problem. So we're getting stuck in here. So we're getting stuck in here. Is the left not moving? One. It's on one forever. While left is less than N and grid I. Oh, I should say not equal to period. Grid I left is not equal to period. I is greater than 0. And I is greater than 0. And something like that. No, we are still stuck on 1. So after I do my DFS, oh my gosh, look at that. That'll do it. No, we were making it out of that though. Okay, I think it was just... Okay, now we're on 0. Okay, let's see what it looks like after that first DFS. Okay. Good. And we're going to go for each row. We're going to say num size is 0. And left is 0. And while left is less than N, we're going to say while left is less than N and grid I doesn't equal that, or grid I or grid I left equals the period and I is greater than 0. Wait. So while this guy doesn't equal period, while it doesn't equal period, you gotta move. Or if it equals period and the one above us and the one above us doesn't equal a period, or the one above us equals a period. Okay. So are we making it out of that? Yeah. So then we say if left is less than n, does it equal less than n? It should. It should actually be 0. Left should be 0. Perfect. So while left is, if left is less than n, which it is, we say right equals left, and then we say while right is less than n, and grid I right equals period, and the one above us doesn't equal period. Huh. Come on, dude. Are we making it out of there? Yeah, we're making it out of there. And then we're saying plus plus num sides. And then we say left equals right. And then something's weird. Then we're making it out of there. Yep. We make it out of there. We make it to there. Are we making it out of here? No. So we're not making it out of this for loop. Oh. Well, yeah, we should say left equals 0. Huh. How are we going out of bounds? Let's see where we screw up. 1. On the second row. On the second row, we go out of bounds somewhere. Well, it tells us right here, see. 107. Right here, we go out of bounds somehow. What? Wow, left is less than n. What exactly is going out of bounds? print out left. And I. So 0, 1. Well, it could be something on the inside there. And I'm saying left is less than n. 4 and 1. Left is 4. Oh, we're saying false. That it's not less than n. Do we have something flipped up here? No. False. That it's not less than n, but I'm pretty sure this one is 4. It's totally out of bounds. What? I'm saying it's not. What in the world? Four. What? Huh? Left. Which is left. Is less than n, which is n. What? Oh. I don't know what's happening. Four is less than n. Right. So, right. It equals n. It's not less than. So I shouldn't even be hitting that condition again. What the heck? Huh? What? Left. False. Oh my gosh. And all of this stuff. I should put all of this stuff together. Upside is 1. That's right. That's correct. Oh my goodness. Alright. So that's the number of upsides. It's absolutely disgusting. Sides. So we have the number of sides. And I have the area, so I'm going to have a sum. Sum plus equals num sides times area. Then I can say area equals 0 again. Reset that. We're keeping track of the visited, right? Yes. Alright. And then should return that sum. And now I need to check. Let's make sure I'm doing this condition right. Well, right is less than n. And yeah, this is fine. Alright. For down, it's going to be kind of the same. Oh, so gross. Oh boy. Now for the downsides. Grid is less than. Wait. Shoot. And now for down, just flip this, right? Instead of being greater than 0, we're going to say less than m minus 1 and grid I plus 1. Something like that. Same thing here. I equals 0 or I equals n minus 1. Grid I plus 1. Same thing, right? I think. And now for the left sides. It's gonna be ugly. For the left sides, we need to loop through wait. How was I doing that here? Yeah. For the left sides, you need to loop through the columns. And so ugly and brute force. I think I'm gonna get this working though. I'm gonna figure it out. Figure out something better tomorrow. Okay, and then num sides. We're gonna have an up and a down this time. Searching up and down. Up equals 0. While up is less than m and grid up's a row now. Up j is, what did I say here? It's gonna be kind of the same. If it's not equal to the period or grid up j is equal to the period and the one to the left of us, j is greater than 0 and grid up j minus 1 is equal to the period. Yeah. It's basically the same thing. Plus plus up, which brings it down. And then I will say if up is less than m, it's really the same thing. Well, that's down. Really is the same kind of, huh? Down equals up. And while down is less than M, and grid down J is equal to period. And not 0, right? Or yeah, we're looking at the left sides. Yeah, J is 0 or grid down J minus 1 is not equal to period. Keep on moving down. Plus num sides, and then say up equals down. Yucks. Sum plus equals num sides. And then it really is kind of the same thing for, right, so I think I could but this is the method. Okay, checking the right sides. Down. We're just gonna flip this part is less than n minus 1. J equals n minus 1. Put a plus Wahio. Oh my gosh. I hope this works. If this, I'll give it my best effort till midnight. Okay. Did I even finish 80? Was that the answer for the sample? Oh, it was. The second example above. What about this one? 1206 is what that one's supposed to have. $12.06. Dang it. Oh, we still have some periods in there. What the heck? Why do we still have periods in there? What the heck? Shouldn't be printing that out every time. Why do I still have periods in there? This is a DFS version. Should count the sides, and then I should reset. Oh, it's periods in there because I'm. Wait. Uh-oh. How's that happening? Wait, what is reset doing? What the heck? After I reset, there should be. Wait, check your DFS. No, what is going on? After I reset, there should be nothing. Printers, print array, the grid. There should not be any dots in there. Wait, what the heck is that one? Okay, okay. Yeah, what's going on right here? What is... Oh, that was earlier. How many times is that being printed? Hmm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm getting 11 regions, is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, right number of regions. I think my perimeter is just off. Yeah, it has to be the perimeter that's off. Something about the perimeter is off. Well, I can check that. I can print that out. Yeah, let's print that out. Plus the area. And the perimeter. Oh, num sides, actually, num sides. Let's just do this down here. See where we're going wrong here. Well, let's just, we don't need to print this out. Ten and 12, 4 and 4, 14 and 20. 10 and 11, 13 and 9, so we're like slightly off. We have an off by not an off by 1, or it could be 1 and 4, 13 and 8. Like we're yeah, we have a slight error. It's really close. I have a slight error somewhere. Maybe an off by 1. So let's see what is it about this region of C's, and what is it about this region of F's? What is it about those? What is it about this region of C's? There's 1, 2, 3, 4, 5, 6. Wait. How many sides? Oh, crap. Keeps going down here. This will be easier to look at in my text file here. Sample 1. So what is it about this region of C's right here? It should be, what is it? Should be 22 sides. Let's look at a smaller one. Let's look at this one. It should be 10 and 12, but I'm getting 10 and 11. Is there a smaller one up here? Yeah, let's look at that one. So this one should be 10 and 12, but I'm getting 10 and 11, and that's the first region of F's. This first region of F's should be 12. I'm printing 11. This one. I'm going to do this. F. So there should be 12 sides. Let's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm getting 11 somehow. Oh, you know what? No, I don't know what. Let's do this. Let's do... Let's do this. Counting sides for... And then... plus upsides. Yeah, I could just say some plus, but whatever. Upsides. Checking the downsides. And downsides. Plus downsides. Downsides. I just want to see which one's off. Left sides. What the heck? Yeah, okay. It's fine, it's fine. Let's go to the first region of F's here. Okay. So the number of upsides, we have 1, 2. That's accurate. The number of downsides is 1, 2, 3, 4. That's accurate. The number of left sides is 1, 2, 3, 4. So we're missing a left side somehow. 1, 2, 3, 4. We're missing a left side. What about right sides? 1, 2. What the heck? 2. Huh? We get 4? Did I print out the wrong thing? I think so. Yeah, I did. So if I'm just getting the left sides wrong, that'd be alright. Alright, yeah, two right sides. So I'm just getting the left sides wrong. There should be 4. 1, 2, 3, 4, but I'm only counting 3. What was the other one I'm getting wrong? It was this one. It should be 22. There should be 22. There should be 22 sides total. So I'm counting 5 upsides. 1, 2, 3, 4, 5. Yeah, that's right. 5 upsides. What about downsides? 1, 2, 3, 4, 5, 6. That's accurate. And then what about left sides? 1, 2, 3, 4, 5. And I'm only counting 4. So it's the left sides, I think. And then what about right sides? 1, 2, 3, 4, 5, 6. Oh, I'm off on the right sides there as well. So something to do with my left and right, maybe? Am I off? Am I ever off for up or downs? I probably will be. Which ones are we getting wrong? 3 and 6, 5 and 6, 14, 16, 13, 18, 1 and 4. Here's another one. 11 and 12 for this region of J's. So I'm saying 3 upsides. 1, 2, 3. Yep. 3 downsides. 1, 2, 3. Yep. I'm saying 2 left sides. 1, 2, 3. But there's 3. And I'm saying 2 right sides, and there's 1, 2, 3. So far, I'm only screwing up the left and right sides. So far, only screwing up the left and right sides. What other one am I missing? That one also. Wait, what the heck? Yeah, that was 11 and 12. And I'm also missing this one. 13. This should be 13 and 10. This is the region of V's. I'm saying 2 upsides. 1, 2. Accurate. 3 downsides. 1, 2, 3. Yep. So my ups and downs seem to be good. What about left? I am saying 2, but there's 2 left sides. And there's 1, 2, 3 right sides. But I'm only saying 2. Now, why would that be? Left and right. Something to my left and right. 10 and 11, we looked at that one. So something to do with my left and right. So let's take a look at that. Doesn't look like it's ever my ups or downs. So what is it about my lefts and rights? Up is less than M. Yeah. And grid up J is not equal to period. Or grid up J is a period, and grid up J, wait a minute, it's a period. Or what if it is a period? Well, if it is a period and the up is an edge. Oh, we're looking left right now. We're looking left. And J is... like if J equals 0, then yeah, we're starting at an edge. I mean, this is exactly like the ups and downs, so I feel like the ups and downs should be screwing up too. Let's look at these. Let's like walk through one. Let's walk through one real quick. Let's walk through one of these bad Larrys. So, what's one I was getting wrong? I was getting F, the F's wrong. So, okay, checking the left sides. Which ones did we get wrong on that one? Wait, what? Yeah, I'll take it once. F, 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 F. Okay, I said 2 left sides, but there's 3. Oh, wait. I said 3, but there's 4. Okay. So for J, the column is 0. We're starting at the 0 column. And starting at this column, so nothing's going to happen until oh crap, I think I see what the problem is. Nothing's going to happen until it gets to here. Oh, I see the problem, I think. So checking ups and downs works because I'm going by row. Going across the entire row. You know, I'm looking up and down. Well, no, I'm checking the whole column. So yeah, I'm going, nothing will happen until I get to this column, and I'm going to get here. I'm going to get here. And we'll get to this one. And I'm going to say while up, well, sorry, actually we'll get out of it. Not equal J, or yeah, J is wait, what the heck? J is greater than 0. Is that flipped or something? J is greater than 0. And it doesn't equal that. Yeah, so we're there. Oh, wait. Oh, and it equals a period. Yeah, so no, we get out. This is where we would get out. And then If up is less than m, it is. We say down equals up. So while down is less than m, grid down j is equal to the period, and j equals 0, or grid down j minus 1, the less best is not a period, then we go ahead. And then we go ahead. And then we say oh wait. Yeah, and then we go ahead. Oh wait. What the heck? Hold on. Yeah, this is not right. I did not do this right. I'm missing my outer loop for these. Oh my goodness gracious. I'm missing my outer loop for these. That will do it. That's what happens when you just copy and paste a bunch. Your code's hard to read, and you make a lot of mistakes. So yeah, I gotta put these in an inner loop, or outer. Yeah, these need an outer loop. Oh my gosh, dude. I just need to say while up is less than m. And just put that whole little chunk right in there. Yeah. Same thing here. While up is less than m. Up is less than yucky. Now yeah, that's definitely a less dumb way to do this. I will get there in a second. Okay. 1206, 1206. Please. Please. Yay! I did it. That is great. If I finish tomorrow's, then I will have made it farther than I did last year. Okay, thanks for watching.